All right, so welcome to the last lecture video of section 10.3. We're going to finish this section out by graphing on an actual calculator. And I downloaded a TI emulator for my computer, so hopefully this works out pretty similarly to how it would in the classroom on the screen. So again, the last part of this section is graphing with your calculator. So we're just going to go ahead and try to graph a couple of these. Now I know this PowerPoint slide already shows you what it looks like, but I still want us to try it on the calculator so you can watch how the curve gets traced, just like we did with parametric curves. So I have an emulator, and I'm going to move it over to the side here so I can type in our equation. Now the difference here is we have to make sure, let me get out of the screen. We have to make sure we click on the mode button and switch our graph type from function over to polar. Now I know in 10.2 we were using parametric, so then now that we're in 10.3 we're going to be using polar. So I'm going to go down to that line, switch over to polar, and now I should be good to go as long as my theta is also in radian mode instead of degree. So I'm going to go to the y equals screen, and now you're going to see r equals. In parametric, we had 2 x and y, and in the function mode, you just have y equals. So now we have r equals, and I can directly type in my formulas. So I have to do a sine cubed, so I'm going to use parentheses. Remember to be very careful all the time. Sine of 2.5 theta, and the theta is on the same button as the x and the t. And I want to cube my sine. So there's my sine cubed, and then I'm going to add cosine cubed of the same thing. So cosine of 2.5 theta cubed. All right, so now we should be able to go ahead and graph this. And you don't see a whole lot. Notice that everything appears to be bounded in between 1 and -1, of course, because we're using sines and cosines, and you can see that already on the PowerPoint screen here. So let me go ahead and maximize now that we're done with the PowerPoint for a second. And let's change our window to have an x min and max of -1 and 1, and the same for y's. -1 to 1. Now what's happening up here with theta? Well, if you don't recognize it, 6.28 is actually 2 pi, 2 times pi. In fact, you can type that in there and you can watch it change to 6.28. 2 pi, and then I hit enter, and that's 6.28. So now I'm going to hit graph again, and we'll see what we get. Whoa, little choppy, huh? And it didn't appear to graph the entire picture. So I think our theta must be too small. Let's go to 4 pi instead of just 2 pi and see what happens. This time we see a lot more of the graph, so that's much, much better. But the graph is super choppy. So if you'll remember from the parametric form, the way we can fix that is with theta step. It was called t-step when we were doing parametric. So let's make theta step smaller than 0.13. Let's make it 0.05 and see what happens. Much curvier this time. Starting out to look like a clover kind of, and then it shifts to do a clover slightly different. All right, now it's finished. So of course, like we saw with parametric, if I make my theta step even smaller, it should be even curvier. Let's find out. Yep, and of course it's slower because it's having to calculate a whole lot more points in order to draw that curve for you, but it is smoother overall. So this is probably going to take several seconds. You can become mesmerized by the screen. but you get the idea. Just like with parametric equations, you can control the choppiness or the smoothness of the curve you're seeing by changing theta step. And you might have to adjust the start and end point of theta to make sure that you can see the entire graph in the first place. If I look at the PowerPoint again, this looks much closer. Now, what you see on the PowerPoint is a square graph. So it looks a little bit different. Ours looks kind of distorted. That's simply because a calculator has a rectangular screen. So it's getting a tiny bit distorted even though we told it to be -1 to 1. But hopefully you can tell that this is the same graph as what you see here on the PowerPoint. Okay? I think it's just about done. And there it is, it finished. So now let's try this second curve. So I'm going to go back to y equals and clear out my first one. And I'm going to put 2 plus sine cubed of 2.4 theta cubed. And there we go. That should do it. And I'm going to leave all the parameters the same so we can go through the process of figuring out what the graph looks like. Again, you've already seen it. It's on the PowerPoint presentation, but let's go through the steps anyway. As a reminder, my theta step is very small, so this is drawing very slowly. And it's kind of hard to tell when it's done, but this little spinning circle at the top, if you have this computer version of the calculator, tells you when it's done. So it's still working. Still working. Need some Jeopardy music. Should be almost done. Okay, so while we're waiting for that to continue graphing, obviously our x and y mins and maxes are too small because I can't see the whole graph. So 1 and -1 is not enough. So let's expand that. Maybe 5s would do it for us. Okay, and I'm going to make my theta step a little bigger so we don't have to wait so long for it to graph each time. I'm going to switch my theta back to 2 pi since that's the standard, and let's start from there. Hopefully, since you can hit pause at any time in the video, you can capture whatever you need from the screen if I'm going too fast. But what we have here is a blob. I think you would agree. If we look at the PowerPoint, that does not look like a blob at all. So first off, you can see that their window frame was 3 and -3. That comes from the fact that 1 is the amplitude of sine, but we're adding 2 here. So 3 and -3 is the perfect window. I was just trying to go at it from the perspective of not knowing the perfect window. So we can change our x mins and maxes to be 3 and -3. Uh-oh, we're frozen. All right, sorry about that. The calculator software froze and I had to kill it and open it back up. So we were changing our window from -3 to 3 on both the x and the y directions. My t-step, I think I had at 0.05. And then theta, I'm letting go from 0 to 2 pi. So let's see what we see with this window. Much faster. We see everything. But then hopefully you notice the graph just sort of stopped. So maybe we're missing some of it. So what if we make theta bigger? What happens? So it draws the curve, and then it keeps going, but with a different curve. So we definitely weren't seeing the whole graph the first time. And again, you can see it stops. So we must need to make theta even bigger to see what's really happening here. So let me go all out and just say 8 pi. It's going to take a little while to graph, but hopefully we'll see more this time. So we have our original blob plus our second blob. These are the technical terms. Sort of looks like a kid is drawing a flower. And now we have a third one. and a fourth one, and it just keeps going apparently. All right, so if we compare this to the PowerPoint version of the picture, are we anywhere close? Yes, we are. You can see that we do have the same graph. Ours looks a little distorted again because the screen is rectangular. It's not a perfect square, but now you can see it. So to summarize, remember that just like with parametric equations, you might have to play around with this window button a little bit and all the items in there to see the entire graph. And it's kind of an art form, not necessarily something that's super obvious. But never assume that you can see the entire graph on the first try. Always play around with your X and Y scales, or sorry, your X and Y mins and maxes, and definitely your theta max. Theta step only controls the smoothness of the curve. The theta max and min can control actually how much of the curve you can see. So don't be afraid to go in there and mess around. You can always switch things back to the standard view by hitting zoom 6 if you need to start over. Okay, so that ends our section 10.3 on polar coordinates. I will be posting some example videos outside of the PowerPoint slides, and these PowerPoint slides will be available also on eCampus. Thank you.